This module, we're going to explore options for integrating with external systems. Let's start off by focusing on compute systems, and then later on, we're going to take a look at data systems. So from a compute system perspective, there are a number of ways in which we can integrate compute services running on the cloud with services that are potentially running elsewhere. One of the mechanisms that's available for us to do this is by creating a virtual private cloud network, a VPN, using services that are available both in the cloud and on premises or across two clouds for that matter. So a VPN essentially creates a secure encrypted channel of communication over the public internet, and it requires devices, which could be hardware or software gateway devices on either end of the networks. In addition to Cloud VPN, we can also implement a physical connection at a fiber level between an on-premises network and the cloud. And this would be a layer 2 or layer 3 physical connection. These connections can be made directly with the cloud provider, or it could be facilitated through a partner. Cloud providers typically don't have co-location facilities where these connections can be established everywhere. So where a co-location facility doesn't exist, it may make sense to work with a third-party carrier. In addition to these two options of connecting networks, there are services which are available within the network itself. For example, some cloud providers will offer the ability for you to enable virtual machines running on the cloud to be configured with private IP addresses, but still access cloud services which are exposed using public IP addresses. So behind the scenes, there are advanced networking configurations that are automatically implemented to essentially keep traffic within the private network. So that's private access. And in addition to private access, some cloud providers will give you mechanisms that you can use to implement a secure perimeter that allows you to add resources which are on premises as well as resources in the cloud and ensure that data can only be exchanged between resources within that secure perimeter. So that's compute. Now let's take a look at the data integration options. Data services do play a key role in enable interoperability between clouds. So we're going to take a look at some of the mechanisms we can leverage. For example, in most cloud platforms, we do have the ability to cache data at the edge of the network, and that could be an effective way of making data accessible across two networks. Obviously, the type of data needs to be carefully considered. You shouldn't really be caching data that is secure in nature. And once data is cached at the edge of the network, it reduces latency. It actually makes data more easily accessible. The other benefit of caching data at the edge of the network is that you're reducing the load on backend resources. So not only can this be an effective way of integrating applications deployed across multiple environments, it can also be more cost effective from a resource utilization point of view, as well as delivering some performance benefits. Object storage services are very popular in the cloud, and many cloud providers offer built-in notification services. These notification capabilities can be used to integrate systems where a system uploads data into a cloud storage bucket that triggers an event which results in a serverless application processing data and making that data available to a system that is running in the cloud environment. In addition to storage with notification, some cloud providers offer advanced capabilities that enable sensitive data to be detected and classified, thereby preventing data exfiltration. Thanks for watching. In subsequent modules, we're going to go through some of the topics we've discussed in this module in a lot more detail.